The last section for Unit 3 is going to be over log and exponential equations. So first thing we need to bring to the forefront is this is exponential form. If we convert this to log form, it looks like this. We've already talked about this, but we're going to use this a lot throughout this chapter. This only works when you have a single exponential or a single log. If we have multiple logs, we're going to have to combine them using log properties like we talked about in the last section. So let's just work our way through these. A lot of these I'm going to refer to using the calculator. I'm going to assume you know how to put in the calculator since we've already talked about that. So let's look at this one. Okay. Now, if I convert, I can't solve it right now, but if I convert it to log form, it's going to be log base 7 of 12 equals x. I've solved for x. This is an exact answer. If I want to approximate it, I will put it into the calculator, and whenever I round, I will be approximating. Thus the little squigglies. And so if I do that, I get 1.28 as an approximation for x. Okay, so whenever I say approximation, it's because I'm putting the calculator and I'm rounding. And whenever you leave it in the regular log form, that's an exact answer. So let's say I have something like this. E to the x squared. If I convert it to log form, it's going to be natural log of 200 equals x squared. So to solve for x, I'll square root both sides. So x is approximately 2.302. Okay, another example. E to the 2x plus 1 times e to the negative 4x equals 3 times e. Now, I cannot convert it to log form right now because I have multiple exponentials. So I need to combine all the exponentials till I have a single exponential equation. So I combine the exponents over here on the left-hand side by adding. So I get negative 2x plus 1. If I divide by e, that's like e to the first power. So I subtract. So 2x plus 1 minus 1 is e to the negative 2x. Then I convert to exponential form. Log form. I get that. Moving up here. So x is the natural log of 3 divided by negative 2, which is approximately negative 0.4549. Okay. Our last example for an exponential here is a little bit tricky. We have 3 to the 2x minus 1 equals 4 to the x plus 2. Now, when we had something look like this in the past, we try to write them with the same base. There's no way to write 3 and 4 as the same base. So we need to start somewhere. So the best way to start here is to take the natural log of both sides. I can do any log. I just choose natural log because it's one we have in the calculator. So if we do that, we can use log properties to simplify and solve for x. So here, I can move these out as lead coefficients, the exponents as lead coefficients using the log property. Distribute 2x natural log of 3 minus the natural log of 3, x natural log of 4 plus 2 natural log of 4. I'm going to put everything with an x on the left-hand side, and anything without an x on the right-hand side. Okay, so if I factor out a common factor of x on the left-hand side, I get this, and then I have then isolated x so that I can divide by that whole quantity in parentheses and get the solution for x. And if I want the approximation for that, I can put that guy in the calculator and you get approximately 4.774. That was a little bit trickier. The trick is always start out with taking natural log of both sides. Okay, now let's move to some log problems. Let's say I have log base x of 1/8 equals 3. If I convert it to exponential form, that's x to the third equals 1/8. And then I can solve it from there using techniques that I have already previously learned in this class. And the cube root of 1/8 is 1/2. Okay, another one. Log base 3 of x plus 2. Or excuse me, I didn't want to do that. I'll do x plus 1 equals 2. Convert it to exponential form. I get that. 3 squared is 9. Subtract 1 from both sides. X equals 8. Another example. Natural log of x equals 3. Convert it to exponential form. That's e to the third equals x, which is approximately 20.09. Okay, now all those were single logs. If we have multiple logs, we need to combine them down to a single log before we convert it to exponential form. So let's say I have log of x plus 6 minus log of x plus 2 equals log of x. I can combine those two on the left-hand side because it's subtraction of doing x plus 6 over x plus 2. And I can just drop the logs from both sides. I can do that. So we get x plus 6 equals x times x plus 2. Give you x squared plus 2x. Put everything on the same side. We get 0 equals x squared plus x minus 6, which gives you x plus 3, x minus 2. So I have x plus 3 equals 0 and x minus 2 equals 0. So x equals negative 3 and x equals 2. Now, when we first talked about logs, I said that the domain of logs is going to be always positive greater than 0. Always greater than 0. So we need to check and see if either one of these are going to make us be taking a log of something that's negative or 0. And you can see that if I have x equal to negative 3 here and here, it's going to be taking a log of a negative. So that's going to give us an undefined term. So we're going to throw that out. Everything's okay with the 2 though, so that's our only solution is x equal to 2. That's our only solution. Okay, so we need to get used to checking our answers. Okay, let's do another example. Let's say I have log of 3x plus 2 plus log of x minus 1 equals 1. Combine the left-hand side by multiplication. So we have 10, because this is log, it's base 10, so 10 to the first power equals 3x plus 2 times x minus 1. So it gives us 10 equals 3x squared minus 3x plus 2x minus 2, which gives us 3x squared. In the middle there I have negative x, and I'm going to go ahead and bring the 10 over, so we get negative 12. Using the quadratic formula, we get this guy. Which gives us plus or minus the square root of 145 over 6. 1 plus or minus the square root of 145 over 6, which is approximately 2.174 and negative 1.840. And we're going to check those back up here at the top. You see that this positive guy is good. We're always going to be taking log of a positive up at the top. But this guy, you can see that if we plug it in here, we're going to be having a negative. Okay, so and even over on the other side, we're going to have a negative as well. So we can't do that. So we're going to throw this guy out. So our only solution is 1 plus the square root of 145 over 6, which is approximately 2.174. Okay, last example. So we have the natural log of e to the natural log of x minus the natural log of x minus 3 equals the natural log of 2. Now right here, these guys are opposites of each other. So they undo each other. So if I do put that in the calculator, all I get is the exponent, which in this case is just going to be the natural log of x. Combine the left-hand side using log properties. It's going to be division. I can just drop the natural logs. So I get x equals 2 times x minus 3, 2x minus 6, negative x equals negative 6, or x equals 6. And it checks out, so that's our only solution. So we'll stop there.